Hi everyone, welcome back to my YouTube channel. So today I'm meant to be working, but I decided to take it off to do this video. It is a video on a project that I started making 3 or 4 years ago. Never finished it there until the Easter holidays. So I built this tank at the bottom of it. So really it's a space heater, garage heater, and all the parts is custom made at home. And I am now going to bring the camera up close and do a demonstration of every part on it or component. And basically the exact same process as the other projects that I have completed on my YouTube channel. So at the end of the video demonstration of the project going and running itself, I will step through the manufacturing process of all the components from the tank, which is quite complex because it's 2 jerry cans brought together in a unique way. This deflector at the bottom of the heater itself, that's all handcrafted, so there's no machines or nothing like that used, as I am at home. These here chamber, this combustion chamber, is 2 6 kilogram hot point washing machine drums welded together with a TIG welder. And what else do we have here? You see, oh yeah, there's 3 wee jockey wheels on it. So basically you have a house burner attached into the end of 2 washing machine drums that were purchased, or just, I think they were purchased off or lifted from Donovan skip, I'm not sure. The time they were giving out stuff, they were able to give you stuff, but they can't no more. So we're going to bring the camera up now close and show you the components in more detail. And then we'll move on to the design process of all the components themselves. I hope you enjoy it. There's a lot of photos of the manufacturing process, because the likes of this wee enclosure in here, it's all handcrafted. It's made of stainless steel as usual. All the wee buttons is all handcrafted, the control is stacked. So this heater actually cuts off and on. There's a probe here at the back, a temperature probe for the atmosphere temperature at the back here. So I'll bring the camera up now close, do a demonstration of the heater working itself after. So that's it, I hope you enjoy. Okay, so we're going to do a quick walk around of this heater itself. I will then run the heater, turn the heater on with this switch, which is ready to go at the minute. You can see it here inside this plastic cover. The heater is plugged in, ready to go. But first I'm going to talk about the main features or main components of the heater itself. So this heater not only has a burner forcing obviously hot air into the combustion chamber that I've made with 2 washing machine drums. So if this burner was to just continuously chuck hot air in here, hot air would tend to rise and it would tend to sit around this heat shield, so there's nothing really pushing it out. So I have designed a system here at the back to chuck or force cool air up and over the top of the washing machine drums through a gap here at this point. So the gap is roughly about 1 inch. Obviously this shield is made out of stainless steel, the same as the washing machine drums. So at the bottom here you can see a 15mm gap the whole way along the fan. The fan is approximately 900mm long. There's 2 of them in that distance. One of them here is 400mm long and 400 and something, 400mm here. The motor takes up about 60mm. So the fan is actually a duct made out of wee stainless. So the outlet of the fan is duct directly into a gap that covers the whole area of the top of the drum where the heat would lie. So that's that. So basically it's a forced air unit that forces the hot air out the front of the actual heater itself. At the bottom here we have another guard. When I get down low here, so this guard at the bottom, or shield, shields the hot air from the tank that I have made. The guard hooks on with nice wee fancy hooks. You'll see in the manufacturing process later on, and at the end of this video, all the build process like that. So that guard's shaped like a bird's wings, as you can see here. So that's all folded by hand. No machine. It's 2mm stainless. It's tracked with a grinder and folded. And the stand that the heater sits on is a tripod. So rather than making the heater using 4 legs, usually what they would be made of, they would have 4 feet on them, I decided to make it a little fancy. As with all my projects, I make them unique, different. We have a level bung here that is welded onto the jerry can itself. That's usually for a pump and a compressor. So this heat shield, as I talked about, this is also mirror polished here. The hot air is forced out through another gap. It's about approximately an inch away from the cylinders of the washing machine drums. The burner itself is attached. The burner itself is attached into one washing machine drum. There is no gap around the nozzle, the outlet of the burner itself. The burner is remanufactured, so it's refurbished. There's new filters and jets in it, and that's it. And we have this fancy lid for the tank. It's made in the CNC machine. Obviously, I have purchased that. So the oil outlet from the tank runs through here, a rubber pipe, up into a filter before it meets the oil pump. This oil pump sucks the oil up for the burner itself. What else? We have this control panel here. It is made out of mirror polished stainless. All these wee buttons is handcrafted. You will see in the manufacturing process at the end of the video. So this bracket bolts directly onto where the burner is bolted onto. That's all in the images at the end of the video. So we're now going to turn it on and show you a demonstration of it working. So when I turn this on, the burner will fire. The burner hasn't been turned on since yesterday. So there's a bit of oil in the pipe. Sucking the oil up there now. Might take a wee minute to start. Oh, there you go. So it's now going. So the hot air is blowing out the front. Not only is the burner going, this fan at the back is forcing air. You can see it spinning there. It's you can actually see it spinning there in the camera. So the air is being forced up through this gap. I can feel it with my hand here, blowing out the sides too. And so that's it. So this stack is set to 10 degrees. So that means the burner will run to 12 degrees, because I have a 2-degree increment. So I'll lower this just to demonstrate it. Up and off. So we will take it to 9.5 or 8.5. So now the burner will run to 10.5 degrees cut out. I have it set at 8.5. The probe at the back here, this picks up the garage temperature, or atmosphere temperature in this garage. It's now at 9.3, 9.5. So when the air has been forced in here, the fan at the back is pushing the air out. They save hot air lying on top of the shield, which with this colour will turn it brown. And it also saves the same from being directly hit with heat. So the hot air is continuously being pushed out, up and over. The heat shield at the bottom keeps the heat away from the tanks itself. This painted tank. So this tank in here is actually quite cool when it's running. So now the heater is now at 10.3 degrees, or this garage temperature. I cut out there now at 10.5. Because I had it set at 8.5, so I could set that 2-degree increment to stay on for 5 degrees, or no, not come on for 5 degrees. So it's let me see. So if I set this now
to, I'll set it 1 degree above where it was at currently. So I'll set it to, actually I'll set it to 10. So if I set this to 10 degrees, it means the burner will stay on to 12. Yeah, so the burner's going to go again now. The burner will stay on to 12 degrees and we'll come back on to 10 degrees again until the air temperature, room temperature drops to 10 degrees. So we'll just demonstrate this working again. The garage door is actually open at the minute, so it's all the heat's going out the door. This is all made out of mirror polish here too, as you can see. This switch is a me and off and on, so I can turn this off and on right now and the burner will stop, so I don't have to depend on the stack itself. These here grommets is, or these glands is all 16mm. One of them feeds to the burner, or to the motor controlling the forced air from the back. The other one goes directly to the burner itself in here, and I can adjust the air for this burner. At the minute this burner is actually burning nice and clean because the filters and the jets is all brand new and there's no fumes whatsoever. So this is the tank at the back. You can see, if you want to see the process of manufacturing it, I would look at the images at the end. There's probably 100 images because it was quite a complex process. So the burner is now going to cut out 0.1 of a degree. When it gets to 12, as I have it set at 10, 2 degrees above its limit, so the burner won't come back on to 10, fall to 10 degrees again, room temperature. 11.9 on here now, so there now, so it's 12 now, it's dropped to 11.9 again. So once that stat drops to 10 degrees again, the burner will come on. Oh yes, I forgot to say that this fan is running on a delayed timer. So this fan stays running for approximately, I think it's 30 seconds after the burner stops. This makes sure all the hot air is forced out off the top when the burner's not going itself. So it actually cools the stainless down, the whole stainless unit. It's stopped there now. I can raise this. I can raise that delay timer to hold the fan on for longer, and that's it. So it has currently stopped. It is not running now. Room temperature sitting at 12 degrees around the stat there, or that temperature probe, and so that's it. I hope you enjoyed. Look at the images. There's a process of building the tank, process of building this fancy control panel. As I say, of all my projects, I go overboard, and this panel was handcrafted using stainless steel. It is polished using the burnisher and the soap bars, the polished bars, blocks, and so basically I can turn it off here and then turn it on again, and the burner won't start because temperature's at 12.3. so if I raise this up, I'll raise it up to, just for one more demonstration, I'll raise it up to, I'll say 10.5 degrees. Does that make sense? No, we'll take it up to 13. So that means if I take this to 13, it means the burner will stay on to 15 degrees. There we go. So if I hit start, so the burner now will stay on to 15 degrees, and it won't come back on to, it falls to 13 degrees. 13 degrees where I have it set. So this burner now will keep rising room temperature to 15 degrees and then cut out. That's it. So again, the air has been forced up and over the washing machine drums, and it reduces heat at this point. It's obviously going to be hot, but it reduces it from tarnishing it too much. And That's the wee wire going to the electronic stack. It's on a wee grommet here. That's it. That's everything. This burner is completely refurbished, painted, soda blasted first obviously. It was stripped into pieces. The jet was replaced as I said. The filters in here, it's important to replace that for the burner to be nice clean burning. That's everything. There's, I forgot to mention, there's 3 wee small wheels, 50mm wheels, 2-inch wheels. They are, one side has brakes on them. That's it. Really, actually works really well. Bring the camera down lower. So the door's open, but I close the door. I'll close the door down here if I have the keys in my pocket, and you will see the burner cut out 15 degrees. So the door's been closed now. So you should see it start rising much more quicker now as it heats up the room. As you can see, it is nearly 13 degrees. So I have told the burner to stay on to 15 degrees, 2 degrees above 13. Do a lot. It's quite cool today outside. So at the minute, this burner or this heater itself has been trialed, where this the best place for this sensor or this wee probe. But at the minute it seems to be working okay there. So there now, well, I've touched that. My hands is obviously a lot warmer than 15 degrees. So it is cut off. But it was creeping up faster when I shut the door down. So now we're going to move on to the manufacturing process. You can look if you want. It's very long around this control panel and around this tank. This tank was actually put together in quite a unique way to make them as tight as possible. So them 2 tanks is brought up to the wells are touching, and they needed to be a breather at the top of the tank, as well as a inlet outlet at the bottom for the oil to pass over into each tank. The tank is 40 litres. So you can see that there's no handles on the jerry cans, it is all removed. Yeah, it's really good. You should look at the images and you will see the design process, the manufacturing process of the tank itself. It is really interesting how I brought them together so tight, and making the outlet at the top and bottom, joining the 2 tanks together to make one. So that's it. I hope you enjoy. So the room temperature here now is sitting at 15 degrees around this probe. When that falls again to 13, the burner will start. I can drop that 2 degree increment to about, I think I can drop it away down to 0.1 if I want to, but I just think 2 degrees is suitable. I could drop it to 1 maybe. Still being trialled. The room temperature is now currently falling again. Well, it's at 15 degrees, still around that probe. I might need to move the probe away from the heater a wee bit. That's it. Hope you enjoy the pictures. Thank you. So this is the very early stages of the heater build itself. 2 washing machine drums being welded together. The next short video clip shows the Also the early stages when the burner was placed in for the first time and turned on. The next set of images is the building of the tripod stand. So this was also a long time ago. So there's the plates are being made for the feet here at this stage. They are all tapped, 4 in each plate. They are cut and welded onto the frame directly. The wheels of the casters themselves are bolted on. The combustion chamber, as I call it, is attached using 12mm stainless bar, just for looks, fanciness, if anything. This was recently been modified to allow for the 40-litre tank during the Easter holidays. So this bar is moved out to the furthest point of that triangle frame, as you can see here in this image. This allows for the 40-litre tank, which wasn't planned at the very beginning. Just to allow more oil, more runtime. This is it, nearly completed. Also at the stages the tank was in process, and also was the forced air intake, or the motor itself. So this next process involves building or manufacturing the heat shield for the top, or the heat deflector. So this reduces the heat from rising and allows it to be forced out the front using the blower unit. It is attached using multiple, or maybe 20 or 30, no 20 25mm stainless bolts. These keep the gap in between the washing machine drums and the shield itself. The next process here is mounting the burner. So this was only recently done over the Easter holidays. Well, finished off properly. There's a wee small bracket made to fit into between the washing machine drum there. It is clamped and spot welded with the TIG, or tacked with the TIG welder. Also, there needed to be a wee bolt welded to it to allow the burner to be tightened. So here the bracket is welded. The bolt then, or a 25mm M8 bolt, is welded into a 16mm tube. This is then welded to that bracket to hold the burner itself. It is spun in the drill first with a bit of sandpaper to polish it up before welding it on, obviously. So at this stage, the forced air unit and the tank and the burner attachment was being done at the same time. This is the wee boss extrude, or the wee bolt attached, ready for the burner to be tried, to make sure it fitted on. This wee bolt also allows the attachment of the wee control panel that was seen earlier in the video. Okay, so this next process involved stripping the burner down in bits, sandblasting it, or soda blasting it, replacing any parts that were worn, such as the filter inside the air intake, the jet itself, the nozzle, and also the fuel pump was just replaced too, as it wasn't very dear, very expensive. So this is the parts being, even inside the burner there is sandblasted and painted with red oxide to stop any corrosion in the future. The cover was also polished up. So this next process involved manufacturing air intake for the burner, so the brackets that hold the blower unit, and also the ducting from the blower unit to the burner itself, to the deflector plate. So this is using the bracket that came off the blower unit as a stencil for the stainless that will be welded to the burner itself. So this is the beginning of the duct that the air passes into the burner over the top of the washing machine drums. As you can see, this is tacked on with the blower units bolted to that bracket plate. This is the ducting work for the top that will be folded at approximately 10 degrees. This reduces obstruction, so you'll see a bit of the deflector plate cut out too, to allow adequate airflow up over top of the cylinder shape. So there's an inch gap, remember there's an inch gap between the washing machine drums and the deflector plate itself. These bits marked out in black here are cut to remove obstructions from the airflow, so the air passes up over. At this point, the blower unit is ready to be closed in with the stainless plates. So 2 stainless plates at the top there, and then 4 plates at the side, 2 in each. As you can see here, the side is open, so this is closed off with small plates, as you will see in the next image coming up. So this is 4 plates, and one of them is a piece of cardboard, I think, with a stencil. So this is them closed up and tack welded into place. So the air now is forced up over the cylinder shape itself. This is the blower unit removed, so the blower unit slides out nice and neat if it ever needs replaced. This is all stainless steel Moore grade finish. So this is the guard that covers the blower motor intake, so it stops anything from falling in, or even put your fingers in there. Okay, so this next process was quite a lengthy one. It was involved making the 40-litre tank. So at the very beginning I was going to use a 20-litre tank, but I decided it would be too small. So what I done is I've removed all the handles off the jerry can, brand new jerry cans, and they were sanded. And these jerry cans are quite thin, so you had to be quite careful not to make any holes. So I've sanded them off using dual action sander, or DA sander, and they're brought together as close as possible. So I needed to work out a way of how to bring them close together, but also welding down the back of them, because when they're together there's only a 30mm gap. So I came up with the idea to use these wee 30mm stainless box irons. So as you can see there, I was going to cut that out, and then weld that piece on to the 2 tanks. So there's one of these at the top and bottom, one for the oil to pass over at the bottom, and one for breather at the top. The holes in the jerry cans are cut out using Dremel. This is the inlet of the tank itself. It is stainless steel. It is approximately, it's 3 inch, so it's 65mm, I think. This is welded on using the big welder. First this is cut out using the die grinder. Rough at the start just. So these jerry cans are coated on the inside, so I wanted to reduce burden off that protective coating as much as possible. This is them all cleaned and ready for welding. Stainless plates is applied to where the spouts used to be, the outlet of them tanks used to be. This is the wee fancy fittings that I have made to bring the tanks together. So first things first, I have welded them on with the MIG welder. They are, 4 of them is identical, approximately identical, and they are laying welded to the jerry cans themselves with the MIG welder. And then the tanks is brought together, tacked together with a TIG, then be brackets, but they are not welded yet. This is the inlet of the tank being welded, tacked on. This is the fitting for the level gauge. So it used to be a hydraulic nut, a 1/2 inch BSP nut. I turned it down the left just so the level bung screws into it. And it's welded to the tank with a MIG welder. The shape, the right angle to so it sits perpendicular to the ground. If that makes sense. This is the outlet. A barbed bit of pipe is welded onto there for the burner fuel supply. So this is the tank nearly finished, ready for painting. We all need it welded up at this stage. And sanded and filled if required. So you can see here the 4 wee fittings I'm talking about. This image shows them better. They are welded completely around the backs with the MIG. The 2 tanks are then brought together, but first they are painted orange. Well, that's the colour I was going to do the tank originally, but it changed then. So I should have done them yellow. So they're painted because the tanks is brought together, they're that tight. They are cleaned then, and then they are welded with the TIG welder. This makes it much easier for the tanks to be brought together. I have also put a bit of epoxy in the inside there, not required, but this is the 2 bits, the 2 fittings brought together, which now makes the whole process easier, such as welding. So I can get in there now with the TIG torch, much easier than trying to get in there with a big welder. To weld it, then there would have been a wee bit rougher doing it the other way. I should have had that tank painted yellow in there, but didn't know at the time. I changed my mind at the last minute. So the whole tank is laying flattened. Well, this is it welded with a TIG, but this 3 fancy brackets. So this allowed the tanks to be butted together. So the welds of both tanks, the beads around the tank were touching. The tank then was ready to be primered. This is a hole for the breather for the very top. I have also placed a wee pipe on it. Just when you're falling oil in it, allows the air to escape the highest point. I don't know why I'm lying on the ground here. I was welding it, that's what it was doing, I think. So this is the mount, or the bolt that mounts the tank to the frame itself. It's M8 and it's 25mm long. It's stainless again. This is the breather pipe for the top of the tank. Barb, I can put a pipe on if needed, but it's not really required unless you're filling the tank to the very throat. This is the tank bolted to the tripod stand. 1 bolt's all that is required. This is start sanding the tank. This is the only image I have of sanding the tank itself. This is testing the tank in a video to make sure there are no leaks before I start painting it. I spilled a wee bit of oil over the side there, but that was easily cleaned up for sanding. So this, you can see there that there's just 2 special fittings welded together to bring the tank close together. There's no leaks, so that's it. Even around the level bung there's a nice seal. Around the outlet there of the tank, there's no leaks too. That black pipe's just they stop the oil running out top and bottom. The breather and the outlet. That's just the level bung, so when the oil goes down low, you can see that there's about an inch to 2 inch of oil left. This is me starting to sand the tank, as I explained before that video there, and this is it, primer with red oxide. Ready for a 2-pack primer. Sprayed outside just, nothing special. This is it with the primer itself. So any wee heights or bumps was flattened, ready for the final coat. So I was going to paint this tank Kubita orange, but I decided to paint it actually, what is it? New Holland yellow. So this is trying to spray in between that gap there at the very early stages before the whole tank was coated or sprayed. It is sprayed, yes, with a yellow New Holland paint. Tractor paint, Vapormatic, really good paint. I use it for all my projects if I'm not powder coating. So it's like an enamel, you know, a really good finish, no haze, you know, if you put it on good and thick. So this is the tank ready for the lid itself. So this is the screw or the meal fitting that will be attached to the 3-inch tube that I have welded onto the tank. It is turned down to slide straight into it, so about 1.5 mil is took off this. 1.5 mil depth, by about 10 mil deep. So there you go. So this is going to be just put on with an epoxy resin, because you can't weld aluminium to stainless. This fitting was made in a CNC machine. It was bought off eBay. So this is cleaning the level bung is going to be screwed onto before it is attached. Also there's a hydraulic fitting liquid sealer used just in case the rubber seal or the fibre seal doesn't do its job right. So this is attaching the tank for the first time after it was painted, after a couple of days. Okay, so this is the fancy plate that looks like the bird wings. It is to deflect the heat away from the tank itself, or that fancy paint that I put on the tanks. It is not folded using a press brake. I have tracked them every inch, and I have shaped the plate into a nice curve, and then at the other end it is curved downhill to keep away just for lux, and also to deflect the heat in the right direction. Really turned out really nice. So basically it was a round circle to start, sheet that I had. It was made for something but I never used it. So I have cut the edges off at the end, as you will see here in the next image. And this is it nearly finished. It is more finished, stainless. Probably too good for the job, but might as well use it when it's lying there, you know. So this is the edges cut off it, ready for the brackets to be made. This is the underside of it. Them's just tracked with the grinder, 1 mil wide. It's 2 mil, so it's very hard to fold, you know. So this is the initial process of building the brackets for it. So this guard or shield is designed to slide into the heater with these wee hooks here. They're bent on a wall with a shifter. These nuts are bored out, they're M5 nuts. The threads are removed using the 5 mil drill. They are then welded onto the actual washing machine drum themselves, and this guard or shield slides into the 2 nuts as they are bored out. and at the other end the shield is attached using nut and M8 screw bolt, dome bolt. You can see it, sorry, it's a hexagon bolt. And the hexagon bolt is welded directly to the bottom of one of the washing machine drums onto a plate for more strength. This is it finished. This is actually changed actually, and the screw goes up into a nut itself now, because it couldn't get the guard on it because it's that complex and tight. The tank was in the way, so the screw actually goes uphill now into a nut itself, so there's no bolt hanging down. Okay, so this is a process that's very similar to one of my other videos, spot welder unit that I built. It is a control box using Mur grade stainless, a burr finish, and it is all fabricated by hand again. So this box took about 2 days itself to make, not including the components or the circuitry or connections inside it that control the motor, blower and the burner, and the delay timers that start and stop the fan after the burner stops. So this is the wee fancy Mur polished box that could have been used built in plastic, but I like to do things different and better. So this is the sides been made for the box. There's 2 of these sides that are just tacked on. It is not welded up totally, it's not required. It's only a heater at the end of the day. It didn't need to be fully welded and polished. So rather I just tacked them 2 plates in to the side. This is me welding, so I've taped up the front face of the box where I don't want marked. This plate is only tacked, as you can see here. Such a lengthy process because of all the wee buttons and gadgets inside were cut by hand with a grinder, and the shafts are only 3mm wide in diameter even, and there had to be a wee window board for the wee electronic stat or digital stat. This is the delay timers that hold the air intake on at the end, so that's me just messing about with a wiring diagram for all these wee modules. So again, you have the forced air on the right there. This is the back guard for the control box. It is folded in 2 places to give you 90 degrees, so 2 45-degree bends. It is bolted directly to where the burner is bolted to. It is Mur polished again. This is where the circuitry will be mounted to, or has been mounted to. There's I think it's M4 screws or countersunk screws, just spot welded to the back itself, and then nylon extrudes are used to isolate the wee control modules away from the metal surface or stainless surface itself. This is stencil drawn out off the circuit board, or electronic stat, digital stat. So this is just bored by hand. 3mm holes, very very small, very hard to bore small holes in stainless in the right place. This whole window was cut out with a Dremel, carbide burrs. Very sharp stainless can be with the carbide burrs. This is the wee Boss cylinder extrudes that the pins will slide up and down. This is me here squaring up the window using the square file. This is all going to need to be polished up to Mur again because I am obviously marking it as I work there. These wee pins is spot welded in the back with a TIG welder. Very 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 precise work. Them wee pins is only 3mm wide. The cylinders themselves are 6mm. And the inside is 3. or sorry, 5mm cylinders and 3mm pins. So this is stainless rivets. I use the 3mm shafts out of them. This is the digital stat mounted on its pads. Very hard to get in there to weld them pins. I should have done that before I folded the box up, maybe. So this is me getting the last pin welded on, or last bolt that holds the circuit board. This is the wee pins that are made to push to control the circuit board itself. They sit into them wee holes there. It's very similar to the spot welder process that I built, the stainless work, the control panel here. So this is looking at the wee pins close to the electronic board itself. Then there needed to be a window made for this too, to keep the dirt out, etc. So just a bit of polycarbonate. So that's all the third work done, all apart from the switch. Nearly ready for burnishing again. I find it's much easier to chop the holes like that than to tidy them up rather than use a hole saw, because a hole saw can run off and they're not very accurate. So what I do is I go inside the limits and move out to the limit of marked with a Stanley blade or something. Much higher precision than using hole saws or even big drill bits. So this is me flattening the back end of the box. The 4 nuts there you see is for they're M5 and they are tacked to the side of the box to be screwed on to allow the fixing of the panel to the back plate that is connected to the burner screw. It is filed flat using the flat file. So this box now is ready for, you can see the hole there at the side for the temperature probe. This is the 4 fixture holes that it will bolt to. A lot of work involved in this box. This is the pads, or the wee mounts. I call them pads for some reason. This is where the wee nylon extrudes screw onto. This is another couple of circuits that I threw together outside. This is to allow the what do you call it, the motor to stay on after the burner cuts out, so it's like on a delayed timer. This is there's 2 power supplies there, there's 2 delayed timers, and if you look at the diagrams in the past picture there, you will see how they are wired up. So the power supplies control the delayed timers, and the delayed timers control the main voltage. So this is the circuits all in position. I needed to make sure that they weren't in the way of the digital stat that is attached to the cover itself. So they are kept down a wee bit, away from it. The box is very complex and very tight. This is me polishing the pins, the 3mm rivets that you have seen. This is me polishing the box back up as it was all marked. That leaves a nice finish on it. It removes all maybe fine hairline scores. This is done using different grades of polish, so black polish, 2 green polish, finishing polish, and from a salsa wheel to a cloth wheel at the end. This is Azimo again, he's on every video. So you can see the finish there with the dog and the stainless itself. The wee hole in the middle there on top of his face is the hole for the temperature probe. Finally, this is wiring the panel itself, so there's mains in, and there's 2 supplies out. One supply for the burner and one supply for the blower unit that forces the air up over the washing machine drums. And this is me wiring. So then we timers or delay timers control single pole relays, 230 volt coils, which can switch on the burner and also switch on the blower itself, the 230 volt blower. Now it's a lot of work, even in down to the wiring here. This is me putting a bit of epoxy on the polycarbonate window. I first used clear, but then I changed it to the ready colour, pink. So there's a lot going on in this box, like a lot of wee fittery things needed to be welded on there, tacked on. Again, there's another wiring diagram. This is a clear window, which is, I don't think it's clear now. I think it's pink, is it not? I don't know, I must have changed it. I think the pink was nicer with the LCD display coming through it and the LEDs. So I took it off and changed it. So this is the box. You can see the quality, the finish on it there. It's really got a mirror finish. This is the main power supply switch. This was soldered on because if you use spades in here, there's no room. The spades would hit the power supplies and the delay timers for the blower unit. So this is me first necessarily trying testing it to see if it worked, which it did, as I demonstrated earlier in this video. It worked the very first time. Okay, so this is the final images of the unit. So this is wiring the control panel to the burner and the forced air unit at the back. Also attaching the fuel lines, etc. And that's really it. This is the final images of the burner or the heater itself complete. I removed that plastic protective coating off the mirror finish, off the guard on the blower unit there, and the shield at the bottom. I hope you really enjoyed. Pull back for more exciting projects. Projects will be much more complex and unique worldwide. And thank you for watching. Ciao, ciao.